All right, hello everybody. It's me again. We are back to talk about some new stuff here in Unit 2. We're going to start off by talking about gravity, gravitation, and orbits. As you can see in the picture, that's the various different orbits of the different planets, and you can see that Pluto has a very strange looking orbit. That's part of why it's not considered a planet anymore. Okay, so we're going to start off by talking about mass. Different objects contain different amounts of matter. Mass is simply how much matter an object contains. This is something you probably learned in ninth grade and probably before that. The elephant and the mouse have a very large difference in the amount of mass or matter that they contain. The SI unit of mass is a gram, so we generally talk about grams or kilograms, which means 1,000 grams. Now, different objects contain different amounts of matter, but matter feels heavier or lighter depending upon the force of gravity. On the Earth, we have gravity. It pulls down towards the center. Weight is the downward pull on an object due to gravity. The SI unit of weight is the Newton. So how do mass and weight compare? Mass and weight are both measuring a property of the object. So if you take a look at that anvil on the Earth, it has a particular weight. In space, it would have no weight. And on the moon, it would have weight, but only 1/6 of the amount on Earth, because that's the difference in gravity. The moon has 1/6 the gravity. So weight is dependent on mass and the pull of gravity. The mass of the object doesn't change. It's the same anvil with the same amount of matter no matter where you have it. Whether it's on the Earth, in space, or on the moon, the amount of matter does not change, but the weight does because the gravity changes. So mass and weight on the moon, you'll see that astronaut, he's not really just walking, he's actually kind of hopping because your legs are strong and they're used to a certain amount of gravity. So when you push, there's not as much gravity on the moon. He only weighs 1/6 the amount that he weighs on Earth. So if he would weigh 180 pounds on Earth, he only weighs 30 pounds on the moon. So his legs would feel super strong. And when he tried to walk, he would actually hop along. So if the sun is the center of our solar system, how do the Earth and the other planets orbit it? An orbit is the path of an object in space as it moves around another object due to Newton's laws, gravity, and inertia. And you can see in the picture, the Earth is going around the sun and the moon is going around the Earth. They are both in orbit. The orbit of one object around another is called a revolution. Here we can see the Earth revolving around the sun and the moon revolving around the Earth. And why? Because of gravity. This is an interesting picture because this is now how we view gravity, that there is a bend or a warping in space-time and in the actual fabric of space. And the more dense or more massive an object is, the more that it actually changes the curvature of space. And the planet then just kind of spins around and goes around and around and around and around like it's trying to fall towards the planet. So, in terms of astronomy, what is gravity? Gravity is a natural force of attraction between two objects. And you can see in the image down below, there's one object that has more gravity, one that has less because of their mass. The amount of gravitational force is determined by mass and the distance between the two objects. So how far apart they are will determine how much gravity impacts the other object. The greater the mass, the greater the gravitational force, and the greater the distance, the lesser the gravitational force. So as you get further and further away from something, gravity goes down. If you climbed the top of Mount Everest, you would actually weigh less than you would if you were down at sea level because you are now further away from the center of gravity of the Earth. You would actually weigh a little bit less. Okay, how does gravity explain how Earth and other planets orbit the sun? Well, the sun's gravitational force is like a string. And you imagine throwing something around, another object that's on a string, and it's just going to keep flying around and around and around that object as long as there's nothing to stop it. And it's constantly changing the direction of the planet's velocity, so it revolves in a nearly circular orbit. Almost circular, not quite circular. Gravity supplies that centripetal force that the planets need to orbit the sun. So gravity is pulling towards the sun, and the planet is trying to fly away. And they stay in that unison as they go around and around and around. So how do Newton's laws explain how the Earth and other planets orbit the sun? The force the Earth exerts on the sun is equal to the amount of force the sun exerts on the Earth. It doesn't seem like it, but it is. However, the sun is much more massive. It's much, 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 much more massive than the Earth is. So this force will have a larger effect on Earth than on the sun. So the sun remains nearly stationary. So as things are rotating, or I should say revolving around the sun doesn't move much. It does wobble a little bit, especially because of Jupiter, because Jupiter is pretty massive, but it wobbles a little as it spins. And there you can see the gravitational pull of the Earth towards the sun. Okay, inertia. Inertia is something that's important as well. Inertia is the tendency of an object to keep moving in a straight line and resist a change in motion. So that object, you can see the car stops, but the person keeps going. And that they will keep going because they don't have a seatbelt on. That's why you wear your seatbelt. So how does the relationship between gravity and inertia explain how Earth and other planets orbit the sun? Inertia means the planets want to keep going in a straight line. Gravity wants to pull the planets towards the sun. So inertia is trying to get them to kind of fly away. The sun's trying to pull them back in. So that balance is what keeps it orbiting and orbiting and orbiting. Okay, Kepler. So Kepler was one of the scientists we talked about before. Kepler determined something about our orbit, that it's actually slightly elliptical. The first law that he came up with said that planets orbit in an elliptical path with the sun as one of the two focal points. There's usually two focal points in an ellipse. Now, because it's nearly circular, the two focal points are basically at the same spot. The second law says the planet covers the same area of space in the same amount of time, regardless of position in orbit. So it has to cover the same area of space. So it's going to go from here to here in the same amount of time as it would from here to here, or from here to here. But for it to go from December to January in the same amount of time, it has to go a little faster because it has more distance to cover. The third law says a planet's orbital period is proportional to the size of its orbit. Okay, so how do these things, what does this say? You know, when you look at this picture, well, we're actually moving a little faster when we're closest to the sun, and that's actually in January. I know, counterintuitive because that's when it's coldest, but we're actually a little bit closer to the sun in our coldest month of the year. Okay, here's another little picture of it. It's just showing the Earth orbiting around the sun, and it's showing the difference in distances. So in January, we are only 147 million kilometers away from the sun, and in July, we are 152 million kilometers, so we're about 5 million kilometers different. So, do planets really orbit the sun? Yeah, but technically, it orbits a center of mass. So the sun and the Earth are orbiting a mutual center of mass called a barycenter. But because the sun is so massive and has so much of the total mass of our solar system, the barycenter is actually located within the sun, not at the very center of the sun, but within the mass of the sun. So that's why the sun wobbles a little bit. So because it's so much more massive than the planets, the mutual center mass is very close to, but not exactly, the center of the sun. The sun is extremely massive compared to everything else in our solar system. The Earth's orbit is almost a perfect circle. And as we saw in that other slide, it's only 5 million kilometers difference from one side to the other. So it only varies by 3% during an entire year. That's it. That's not very much, but it's enough. And that's actually it for this section. So I'll see you in the next one.